So I was able to automate the exports for Windows, and I couldn't test on Linux because I don't have the template for Linux because the compile version that I'm using is different. So the scene that I have there requires a different class. I guess I can test with the template from the website that is on the other path, but I'm not that interested on doing that now. What I'm gonna do now is to explain how the editor export system works, and I'm gonna explain the parts that were confusing to me, and talk about like one of the problems that I had, which is still kind of confusing to me, but I think I have a better idea now of how it works. So I'm gonna explain the confusing parts and how the overall system works to create exports from C++. So I'm probably gonna go over with the debugger on the uh, with VS Code on the editor version, then open the and try to export and set the debugs and go over the breakpoints and then explain. Then after I do this, I'm gonna try to implement the web version, and I might not be able to do it because I already did it from the editor, and I couldn't get it to work. But I'm not sure if it's because of the project that I have there or like something else. So I'm gonna try to try to build it and figure out. But it's not that high of a priority for me now. So I'm just gonna set up the functions probably and just try to set up the pipeline for the web. And then if it doesn't work, I'm just gonna move on and continue to develop the scene. But I'm just gonna explain now. Just gonna, yeah, wait, just save the stream. So I'm gonna go over with the debugger here. Probably gonna explain the version that I have there. But basically what I did was just get the code from the editor and then like remove all the parts that I think that are not necessary and then just put on functions instead of classes. And I think I'm gonna explain the one that I built there as well, probably. Yeah. Oh, I'm gonna put a clock here. Just gonna put fire. Can go over manually, but I think it's probably better to go over with the editor because then it's easier to see visually from the editor's perspective, like what the C++ code is doing. It just takes a long time to load the editor at the beginning. Yeah, so to export the project, you just go on project and export. Then this part doesn't matter on the code, but it's gonna open this. If you don't have the presets, you just click on add and click on one of this. And then you click here on one of the options. And I'm not gonna explain the preset part because it's not relevant to what I did. But basically what the editor is gonna do is gonna cache everything on a file. Which is gonna be the exports underscore presets config. So this file here has key value pairs on a certain way that are gonna represent the values they have here. And the class that controls or displays this stuff is going to be the one that has the first breakpoint there, I think. Just project export dialog or something like that. So I'm doing for the basic version here. In order to have code sign, you need to figure out on a like you need to do something on Windows that's like get a certificate from a trusted authority and you have to pay. And this is so that the executable doesn't display a warning before you execute. But I'm not bothering with this now. So I'm gonna do it with these options here, which are the basic ones. And this embed package here means that if you turn this on, means that you're gonna write the information for the game instead of the executable of the engine. So the way that it works is that you have this export path here, which is gonna be the path that you're gonna export to. So like it's the path of where you want the final executable to be of the game or application. And what the editor is going to do is going to look for a predetermined path, which is on the app data of on Windows. That's going to have the template engine. The template engine is just the compiled engine. So you can do this yourself by downloading the source code and then running scrolls to compile, or you can get from the website. If you want to customize the engine, like add more classes from C++, you need to build the template again, because all that is happening is that the editor is going to get that executable and it's going to copy all the information of that executable onto your final one. So it's like the engine is the baseline of what exists on the file. And if you don't compile a custom engine and you add new classes to the engine and your game depends on those classes, the exported version is not gonna be able to get those classes, because those classes don't exist on the standard compile version. Because the standard compile version is just the engine with whatever it comes from the source, without your classes from a module, for example. So if you wanna add the classes from a module, custom classes, then you need to compile the engine again, and that's gonna serve as the base executable that you use. And then on the export pipeline, you have to specify on the custom template the path to that executable. Then the editor is going to copy the information from that file into the final export path you have there, you select. But it's basically going to be on this path here. It's on the C, users, your username, app data, roaming, Godot, and then export templates. And then here's going to be based on the version. So if you put the templates here, that's how the editor is going to automatically find. It searches for this path here. I'm going to show on the code there. But you can put this custom template paths here, which is what I said. When you build the engine on your own, you have to put the executable you got from compiling the engine. So I'm just going to click on export, and here just going to open the dialog to show the path you want to. This is the path that the final executable is going to be at. So I think now. No, I'm gonna go. Yeah, so this is the part that I stopped. So this is the main class that manages the dialog that was showing there, which has the preset options. So this is the class that is responsible for creating that dialog. So the editor export project dialog. And this platform here is gonna work based on inheritance. So there's a base class, which is for all platforms, which is this editor export platform. And then for each platform, there's gonna be a class that derives from this class here. And then basically just implements the methods for each platform, because obviously everyone's going to be different. So that function here is the main entry point. This is on the beginning of the export pipeline. This export debug is the options you have there. This is the class that determines the options on the, like for example, the embed package is one of them, and then the code sign and the other stuff. So it's going to be on this. There's going to be on the export presets, I think. Yeah. This one is getting from, this option here specifically is getting from the check marks when the file dialog opens. That checks to see if you want to export with the debug or not. And I think it's going to be here. Yeah, so editor export preset. This is the class that manages the logic for the options of the export. And this get export path here is going to be the path you selected where you want the export to be exported to, which in my case would be like the text.x. So you can see here, there's going to be that path that I selected there on the file dialog. This is just Godot official, then task.executable. Then it gets it does everything based on this class here. So it's getting the preset options, and then it's gonna change the state of how the logic, the control flow happens across the exports based on this class. Then the template path is the one that I talked about there. This is this is gonna find the app data executable there, and it's gonna be based on the architecture and the name. So this name here is just building the name of the file on this path here. So in this case, it's gonna be Windows, either the debug or the release version. So has the Windows, then the target. It's gonna be either debug or release, and the architecture, which there are several options there. Don't know if I erased. Basically, on my system, I did it different. I think I'm gonna explain how I did it on mine after. But this is basically the options of architectures for Linux. Is x86 64, then 32, ARM64 32, RV, PPC, and on Windows, I think are these ones. But I'm not sure. But I think these are the options. But these again are the options that you have on the presets there, configurations. And the architecture is just the way that the computer is gonna have hard coded on the hardware. The control or the logic, the ROM is read-only memory, or EEPROM. I think is erasable, electronic erasable programming read-only memory, programmable read-only memory, which is the hard-coded binaries that the hardware is gonna have to determine the control logic of the hardware itself. So that's why I have multiple different architectures. And then it's going to use this editor paths here, which is a class that the editor uses to manage these paths, to get that app data path, which is based on the version and the file name. I'm going to skip this. It's basically going to get that path. So you can see here, there's app data roaming, Godot, whatever. So if you want, like the easiest way to make a custom template always work with the editor without having to specify the path each time, would be just to compile the engine, get the custom executable you want, or download the custom executable from somewhere. Then you go to this path here, put the version there, and then you just replace the file name with your executable. So just replace the file, and then the editor is gonna automatically know that it's gonna get the executable from that point. There is a file here in Python. There's a generator C header file. So like Godot is gonna generate the moment you build the moment you build the engine. Godot is gonna use a Python file to build a header file that is gonna contain the version. I think I can find based on the macros there. So there is a part of the. On mine is easier because there is less functions, so it's easier to find. I think it's spec something. It's on the embedded, I think. Windows inbound. Oh, I think it's probably on the save pack. Forgot which function does this. Yeah, here. Yeah, so it's basically this header file here. So the engine, the scones logic, which is basically Python logic, is gonna build this file at build time based on some Python logic. If you can find here, or say version generated. It doesn't matter that much for explaining the rest of this stuff here. I'll probably look into this later. But this is basically the version here, and that's how it's gonna find. That's what it's here. So the moment that you build the engine, it's gonna have this Python logic that generates the version based on this. So it generates the header file, and then uses that header file in some other logic in order to check. So the editor paths there probably has a logic that uses this header here to find the path based on the version. So if you want to manually change the version, all you have to do is search for this file and change these values here. Then it's gonna change the header. It's gonna change how everything works. So I'm not gonna spend too much time with this now. Just gonna explain the rest. The DLL is also I'm not gonna look into because I didn't use now. So maybe later when it for Steam I've seen that you need some DLL to make the Steam version work. So probably when it gets to that point, I'm going to go back to this and figure out again. But I'm just gonna go over the simplest version possible, which is the one that I have there now that I automated. So this is whether or not you're gonna embed, which is true there for me. Which means it's gonna write to the same executable. It's gonna write the data for the game on the same executable that's REST engine. If you don't select this embeds, then what Godot is gonna do is just gonna write the same data but for a different file, which is gonna be the doc package file. So you're gonna have two files. One is gonna be the executable, which is just the engine, the compiled engine executable, and you're gonna have the package file which has the data for the game. So this is one of the parts that starts getting confusing. So what the editor does is to create this temporary package file first, and then it calls this function here to write data to the package file. So there's three paths here that matter. So one is the template path, which is the path to use the path for the base engine executable. Then you have this P path here, which is the final path where the executable is going to be located at. And then you have this temporary path, which is a temporary file that the editor creates in order to write the data for the game temporarily using this function here. And then later what's going to happen is that the editor is going to get the data from the temporary file and write to the final executable file. And I think this could be changed, but yeah, it works like this, so I'm probably not going to change, but you could do it a different way, I think. But here again, so just going to find the template path. And this is another part that is confusing and is one of the main reasons why I was having problems before. So what this does here is to get the console version of the executable. So the moment you compile the engine for with the target release or target template release or template debug, what the build system is going to do is going to put compile flag options that build two different versions of the executable. One is going to be like the base version that is like considered to be the GUI version, and the other one is going to be the console version. And the console version, when you run the executable, is going to run a command line along with the executable so that you can see the outputs. So if you have these two base engine versions and you select an option here on the presets, then what's going to happen is that Godot is going to build these two different final exported versions. But the way that this works is kind of confusing because here, like this is one of the main parts, the main keys to understand how it works. That this function here is from this DNAccess class copy. Is going to get the template path, which is the path of the base engine executable, and is going to copy the information from that executable to the final path, which is the P path, which is going to be the path of the exported executable. So in this case, it's the temporary file. It's not the final file. So it's writing the information to the temporary file first. Then it's going to use that temporary file to write to the final executable file. But then here, if you have the option as well, it's going to get a different path. So it's basically the same logic, but it uses a different path to write to. And the difference between them is that the console is not going to have the package data embedded into it based on the logic of the editor. It's just going to build the final, it's basically copying the final console version of the engine and it's not writing any extra data to it. Except on Windows where it uses rcedit to change the executable, which is the next step that I'm going to explain. But that's the main difference between these two versions. The normal version is going to write the additional game data inside of the executable, the final exported executable, and the console version is just copying the whatever exists on the template, which is the console template, which is different than the normal one because of the build system. So hopefully this is understandable. So the key to understand is that the console is only going to work if you have a package file inside of the same folder, or if you have the other executable inside of the same folder. So it gets the data from outside of itself, based on the current logic that is at here. So obviously you could change the logic to make it work, but now I'm going to talk about this later when it gets to the final part, because that's one of the related to the problem that I had. So here is just copying this path here, which is the console path, which is this executable here. So the first one, it copies the data from this one to the final, or to the temporary file. And this one is going to export directly from this console template to the final executable path, which is going to be the same name as the other one, but with this other extension here. Just copying the information. The path to the other. This is the first step of the process. So now the temporary file for the standard one has the base engine executable information inside of it. And the final console executable has the base engine data as well. So after it does this, on the Windows version, on Linux it doesn't do this other step, but on Windows, it's going to use this rcedit to... rcedit is a program that, oh, it might fail now because I moved the path. So maybe it fails now. So if it fails, I'm going to show on the other one that I put on the hard-coded path. But the way that it's going to get this rcedit executable is going to be based on the editor settings. So rcedit is a program that's on Windows that allows you to change an executable by writing data to it. And this is also based on the export preset configurations you have. So this here gets the setting from the editor. So if you go on the editor and click export Windows rcedit, you can put whatever path you want, and it has to be the path for the rcedit executable. And then after this, it's just gonna get the information for some information for the game. So it creates a temporary icon. It gets the icon from the game, which comes from the settings as well. So it's gonna depend on here, but it's basically getting from application. So if you have modify resources set on the presets, it's gonna get the path for the icon on that, whatever path you put there, or it's gonna get from the project settings. So I think it's either one. This global get here gets from the project settings. So if you go on project from the editor, you go from project and settings, and then you travel this path here. Click on the application, then config. You can put whatever path you want here. And then what it's going to do is going to copy that to a temporary file as well, in order to use that temporary file. So it's copying the icon image into another temporary file based on this specified path here. It's also standard from the editor. In order to change the original one. So it creates the temporary one to use on rcedit, and then it deletes in the end of the function. I'm not going to go over this function, but this is basically what the function is doing. And this is the standard path that they use here. So app data local is for these temporary things that the editor does. And the app data roaming is for user settings and this other stuff that's more like, it's kind of more like a cache for specific configurations. And the local is more for temporary stuff. This is basically on the preset configuration, which is the options for the game there, that you put there. Then based on this, all that is going to do is going to, the first argument is going to be the path of the final file to the temporary file. So it's changing that temporary file. And the other ones are going to be the arguments, which are going to be based on the preset configuration. There's just building a giant command line command. And it's going to use the OS class to run this command here. So it executes based on the rcedit path. So it's basically just executing rcedit from the command line, passing these arguments here that are flags that depend on the configuration you put on the preset options. So it's probably gonna fail because I don't have. Maybe I changed and I don't remember the path. So it looks like it's working. So I probably changed the path or whatever. So here they list the temporary icon file. So basically this snap is just using on Windows. It just runs this on Windows. On Linux it doesn't do this. In Mac it's gonna be different, I think, as well. But it's just using this rsetted executable to change the final path, which for now is a temporary file, and then it's gonna do the same thing for the console version. In the console case is already the final file. So this case is the temporary file, the main case, and the console case is gonna be the final file. And for the console case, that's all that it does to build the final executable. So it's basically the engine and doesn't do any modification. So I believe that if you move this console here to a folder that has either the package data for your game or has another exported executable for your game, you're gonna be able to run it because it's just basically the same thing. And obviously you can change the code there so it embeds on the thing, but I didn't do that. But I want to explain there later how it works. So here I have my exports, the automated ones. We're just gonna test something to see if it works. It doesn't work. So maybe it's probably because of the RC edit, I think. Yeah, it must be the RC edit because it doesn't write any data to this. And this is the final one. This is the function that is gonna actually write the data to the temporary file. So this is still the temporary file, and not the final file. It's gonna use this as the package path on the embedded case. On the other case, gonna create this other file here, the dot package extension. And this is the main function that is gonna actually write the data to the executable, the data for the game into the. In this case, it's the temporary file, but then it's gonna translate this data later. So it creates this other file here. This part is confusing as well. But the way that it's going to work is that it's going to pass this struct here to this function and this callback functions. This is the function that is actually going to save the data, write the data to the file. And it's going to write based on the file here, which is this temporary file here. So it has a temporary file and a temporary path that it has here. Temp path. So I created this temporary file and puts this file on this struct here as the pd.f. So on this function, I'm not going to go over all the functions, but basically what it does is, again, from the presets configuration, is going to, depending on the option you put there, is going to find the resources for the project, and is going to use the editor file system. The editor file system is the class that manages the files on the editor. So it uses this class to find all the resource files that are on the RAS path, which is the path for the project. And then it's going to put them all on this hash set here. In this case, have a couple of GDScript files and some scene files. I'm not going to go over the GDScript ones because I'm not using GDScript. So I'm going to go over the scene ones, but it's basically going to be the same logic. So like here is just filtering files that it doesn't want to export. Using this function here from the, it's filtering from the paths hash set, which has the paths for the resources. And here's for the encryption. I was thinking about using encryption, but I think it's probably not very, like, it doesn't do much, I think, because you have to, it requires you to put the key inside of the executable anyway, so I don't think it's that secure. It just makes it a little harder to reverse engineer. And then here basically uses plugins for either GD extension and the GDScript files. And if you want to customize stuff as well, it allows you to do that. But I didn't look into this, so I'm not going to go over. But it's basically the same logic. It's going to use the paths there for the resources. And it's going to use the function to save the resource based on the file formats. So this is the main function. So this is going to get the paths from cache. On my thing, I didn't do this, so like it's not necessary to call this function and to create the other paths. But basically what the editor does is that it gets the resource files and then creates a cache, creates a different file for each one on the predetermined path, which I think is also on the app local. And then it caches those paths. And it does that because sometimes it changes the format of the file and the structure of the file, and it doesn't want to break the original one. So it's kind of like creating a copy and then changing that copy and then using that copy on the final exported executable. So this function is the one that does that, and then it returns the path. If it didn't change the path, it's just gonna return the original one. But if it changed the path, then it's gonna return the changed path, and that's why it compares the paths here. So if the paths are different, basically what is going to happen is going to push that into a vector, I think. It's going to push that in some data structure, and then it's going to use that data structure to change the project settings. So it's going to save the remapping of the paths on the project settings, and then it's going to save the project settings on the final temporary file that is going to be exported. So the moment the game runs, it's going to have that data inside of the project settings because it's inside of the executable. So it's able to figure out, to remap on runtime. It's basically this class here that they use to create the cache, this export cache here of the paths. I'm gonna put 2 breakpoints here. So the first part there is for import files. The one that matters for me is this one, which this path here is for the scene files. So I'm gonna put another one here. This is basically getting the paths, and it's gonna write to the file as well. So this time I already have, I think, on the cache that this is the class that they're gonna use to keep the paths, to save the paths. And they use this MD5 thing. I think it's a class. Yeah, file access MD5 in order to make the file unique, the file that is cached. So like they get the original thing, they create another file. The name of this file is going to be based on this MD5, so it's unique. And then they change this temporary file in order to save the temporary file on the final executable. I think the paths are different. This paths remap is the thing that they are going to use later. So it's a vector. So they're going to use the remap of the paths to save on the project settings there later. So this function is going to get the path to the scene file, the temporary scene file that they created, which I think is on executable format. And it's just going to use file access, which uses an OS API functions to extract the bytes from the file, the binary data from the file, and then it's going to put that on a vector. And this is basically what this function is doing here. It gets the data from the file using this get buffer and puts it on this vector here. And then based on this, it's going to use that to save that into the final executable, which now is the temporary path there. So it's writing to the temporary file now, the contents of the scene file. And this packet data here, this is the thing that came from the other function. So this is the original one that had that other temporary file that they created. And this part is the one that I mean that's very confusing because there are a bunch of temporary files. But this temporary path or temporary file, this PDF here, is the standard temporary path that they use to create this file just to write the data for the game. And it's coming from the other function there. Yes, basically from this function here. So this ftmp here, which is the temporary file based on this temporary path, which comes from this. This here is the same as calling OS, the OS get cache dir. It's basically the same. Yeah, so he created that file. And this packet data is going to be the same that it has there. So it's basically getting the path to the sync file, which is the export path that it got from the other function before, which has the temporary file name, which is based on this MD5 here, and this other pattern, which is basically the path to the temporary sync file that they created. So they are storing the path and the data for the file on this save data struct. Yeah, so the size, the position, and so basically the metadata for the file is being stored on this save data struct, and then you use the save data struct to put this on this pack data here. So like each sync file that is saving to this other temporary file is going to store on this struct here because it's going to use that later to save to the final executable. So here is getting the file from the struct there, and it's gonna store the information for the file on the struct. So like this ftmp here is the same one that exists before, is this one here. So this file here, based on this temporary path, is the one that they are using here. So it's the same file from the other function, and here they're writing the data for the sync file onto this other file here, this ftmp. Then they write some additional formatting stuff, and then here they're gonna use that same struct to keep track of the files that were saved with the save data struct here. So this one has the information for the metadata of the sync file, which has the path, the size, the position. So it's like they're starting the metadata, and they're pushing to this thing here, which comes from the original struct of the other function. So each file that is saved is going to be on this thing here, on the vector here. And the information for the file is already written on this temporary file based on this star buffer stuff here. So it's going to do this for all the paths that it has on this hash set that it gets from this thing here. So it's looping over the paths that come from the hash set that it got from the editor file system. So editor file system scans the RAS path of the project, gets all the file paths for the resources. Then they filter the ones they don't want to export based on the other functions. Then they loop over all the resource paths. They get the cached version. If it doesn't exist, it creates another file with the MD5 pattern and checks here and then pushes to this path remaps vector to keep track of the paths that were changed. Then uses this get file as bytes to get the byte information for the file. It pushes the path of the file and the byte information to the save pack file function. The save pack file is going to save each file on the pack data struct, and it's going to save the metadata on the saved data struct. And it's going to write the information for the file on that temporary file that they created on the other function, which is this one here. Is saving the temporary data on this file here. So it's going to do this for each resource file that you have on the project. Yeah, I think here is just storing the information for the files on this file cache system here. This has to do with the cache of the resources there. But it doesn't matter that much, I think. So I'm gonna move on to this other parts here. Yeah, so this is the part that I talked about. So based on the files that were remapped, they're gonna loop over them, and then they're gonna save the data as well. So they save with a different name. So they save the original one and the one with the different path based on this. So it's the old path with the dot remap at the end and this new file information. I didn't spend too much time on this because I didn't use this. But it's basically what is happening, just using the remaps, path remaps vector, save the files, but after it's gonna also save on the project settings. So it's basically the same thing. It's gonna use this function here. The only difference is the path that is passing here and the data probably. Yeah. So it's the same file originally, but with a different extension, the dot remap. Then it saves the data as well. So after it does this here, on my case, I put some like extra information. Here they have some like the standard stuff. So it gets the path of the icon of the application based on the project settings. Then it gets the path to the boot splash image, and this image here is the one that shows before the game loads. So I can put a custom image. All I have to do is just download, I think it's PNG, the recommended format, but I could be wrong. And then you put the path from the project settings, and it's gonna get that path from here. And it's gonna push this to the files. So it's just like the icon and the splash, basically, and some of this other stuff here that I don't know very well, but it's getting those files, and then it's gonna write those files as well in the same way that it did for the scene files. So it uses the same functions. This is gonna be the save back whatever function. It's also gonna write the information. So it's basically the same function. It writes the information on the temporary file. Then here is the final part. And this is the part where it's going to write. It creates a temporary project settings file. So the settings of your project are stored on the project.godot file. And here it creates this temporary project.binary file with this extension here. So it's basically this path, in order to save the project settings data for your project on a temporary file. And this one is going to use the custom remaps and this custom list here to save the remaps that happen on the project, on the project settings. So it's saving this information here on this other file here, this temporary file. And then it's going to use that to get the bytes here and to also write into the final temporary file. So this is the reason why it's possible for when you run the executable by itself, for it to know how to structure the project, is because it's writing the project settings into the executable with this stuff here by passing this relative path and using this temporary project binary file. But the function is the same, so I'm not gonna go over. So basically this part, it wrote all the information on this temporary file here for the project. So all the resources, the paths, and it saved the metadata on the structs. So resources, project settings, and it wrote project settings and the resources on the temporary file, and it stored the files on this struct here. Then on the embed option case, that's when you're just gonna create uses the initial temporary path that it got from the other functions, which is just the final path for the export, but with a different extension, which is this .temp. So it's gonna use that path now to get this file. Then this file here at this moment, the only thing that it has is the base engine data that it copied on the prepared template. So this temporary file here is as if it's like the base engine. So it's writing this this custom information here, which is going to be like the how Godot is going to figure out whether or not the executable has the information for the project from the base engine. So it's as if you're writing to the base engine, but you're using this temporary file to store the information. So it writes this standard thing here, which is the header, the format, and the version of Godot to the temporary file. And after it does this, it's going to go over the files that is stored on the struct that it got from the other files. So this here is, if you remember, is the save data struct that store the metadata for each file that is saved on the other file. And then it's gonna use this to write to the final temporary file, which has the same path of the final exported executable you're gonna have, which is the .temp file. So I believe it's writing the it's writing the metadata here and not the contents of the file. So it's writing the paths for each file, the size as well. Yes, the offset size, MD5. So it's basically writing the metadata. It's not writing the contents of the file onto the final file. So first it gets the base engine, writes to the temporary file. Now it's getting the metadata for each file and is writing after this packet thing. So it's base engine, this packet information that is going to determine where the package starts on the executable. Then after that, it uses this struct to write the metadata for each file on this loop here, based on this. And then at the end here, that's the part that was confusing, is going to get this other temporary file that it created, which is the file that stored all the actual content of the files. It's going to use this to write to the final export, which is the other temporary file. So this FTMP here is the file that has all the data for all the resources of the project and the project settings. So it's using this here to get the information and store on this buffer here. So what this function does is to put the information for the file on this buffer. So it's getting the binary data from the file, putting in the buffer, and then based on this value here, it's going to store on the other file. So this one is the actual final one you're going to have. So there's two temporary files. This one, which is the FTMP, which was used to write the data on the other function, on the export project file function, this function here. And you have the original file, which is going to be the final file, which is this one here, that it wrote this header format here, the file metadata, and now it's transferring the data from one temporary file to the other using these buffers here. And that's where it writes the content for the resource files into the final one. And does some additional formatting if you're embedding the data on the executable, which is this part here. You're just gonna add additional headers here. And that's basically all that this function does. So at this point, you have the final export file with the temporary extension with all the information for the package, for the project to work inside of the executable. But this is what this function does. And always, everything is stored on this path for now. It's basically the executable, the header data, and the project information inside of the final temporary file. Then this part here is the one that I was having problems. So after it does this, this is for when you're embedding the data on the executable, it's going to call this function here. So this function opens the file we have so far, which is the .temp file. And it's going to look So this is the part that I'm not 100% sure. But I think that these values here, they are based. I'm very confident that this is the case because the Linux version is different than this one. So this is the Windows embedded, fixed embedded package, and Linux has a different function. So I'm pretty sure that these hard-coded values here, they are based on how the operational system expects the executable to, is the executable format. And you can search for this based on this P header here. So Windows has a format and Linux has another format, which I think is ELF. So Linux uses ELF and Windows, I'm not really sure which format they use. But if you search for process header or something like that, you're gonna find a bunch of images and resources. Just basically the information of the structure of the executable that the Windows expects on the file. So it's gonna be something like this. So like there is predetermined standard information that the file needs to have. And they use this hard-coded values here to move the pointer of the temporary file to that spot. So here is trying to find like, and this is the part that is kind of confusing because I think that this comes from the compiled version. So this is not something that they write on the, yeah, they don't write this information when they are writing the package information, the package data, like on this process here. This information here comes from the base engine template. So it's already coming from this stuff here. So the moment that it writes the information that is checking here is the moment that you compile the engine before to create the template. But then the part that I'm not 100% sure is the sections part here. Because this is how so after it moves the pointer to a certain location based on these values here, it's gonna try to find this pattern here. And that's how the engine is gonna know, it's gonna find the package on the executable. So this part was confusing because the problem that I had on my version is that I was using the console executable, the console template to look for this package. And the console sections are different than the base engine sections. And that's the main difference between the console version and the base template version, the template debug or template release. That the template release and template debug are gonna have this package section here because the sections are different. And I think that they are just the sections of the executable that are predetermined by the operational system. But I'm not sure about this specifically, this string here, if this comes from Godot on the build system part, or if it comes from the from the export system. I think it comes from the compilation process on the ascons, but I'm not 100% sure. But if you try to use the console as the path here, that's you search as this file here, then you're not gonna get this section here, so it's gonna fail. So the console part is just the prepare template and modify template, and it doesn't do anything else with the console executable after that. And only the template debug and template release it searches for this thing here to do this fix up on the executable. So you can see the sections, and this I remember from assembly as well that these are standard sections that you have on executable files. Because the way the operating system is going to work is going to read the file on that specific format, which I believe it comes from assembly. Like assembly, you have those sections of what each thing is going to be on the executable. So it's basically like a file, which is 4 kilobytes, I think. Each page is 4 kilobytes, so the operating system creates an abstraction which is going to read those sections of the file, and then it's going to use that to manage the execution of the program, which is going to be the process. So these sections are hard-coded on the file, and that's what you see here. The one that I'm not sure is the package. I'm not sure if this is written on the export part. I don't think it is because, like I said there, like it doesn't look that it has anything that hard codes this. It only has the headers, but the headers they write different information. Like those macros there, that's the other function wrote. They write. They don't write this package string here. They're writing other strings, which makes me think that this comes from the build system, this cons build system. And it's going to use the same comparison here when it's loading the project. So it's going to figure out that the executable has the data for the game embedded into it based on the string comparison here. Because the loading of the project, the process to load the project, is basically the same thing that it does here. It just reads the file itself and then tries to find these patterns here to bootstrap the project. Yeah. So after it does this is for if you're linking with dynamic linked libraries, which you're not doing, and if we're gonna assign the executable. Maybe I missed the. It probably comes after. So it's probably here. Yeah, so here, so after it does that, all of that, then finally it's going to call this function here to rename the file. So this is the final part. So this path here is the temporary path, or this is the executable path, and this temporary file here is from the other path. The package path. The package path is the one that's it wrote everything to, which is the temporary path. And then at the end, all that it does is just change the name of the thing, so it changes the extension. So this is gonna create the final executable there. But it's basically the same thing. So it uses this .temp path, writes everything to it, and then at the end renames to an executable. But it's basically the same file. I think that this is it. So after doing all this, you're gonna have the final executable there. So the way that it works is basically at the end you're gonna have a base engine, which is the compiled source code using source or your target platform. Then you're gonna have the packet header information, which are the macros there. Then you have files, metadata, a path, size, offsets. Then you have file contents, and then embedded additional info. This one, the string is the one that I'm the most uncertain about, but this is basically going to be the format. And because it has everything on the final executable, then the Godot is able to find the information for the project without relying on external files. So everything is written. So I'm going to show there on the main how it does this. So when you're running the project from the exported point of view, so the final exported executable you got, Godot's going to run this main function, and then it's going to run this setup function from the project settings, which calls this one. And this is the one that looks for the information on the executable. So it gets the executable path, which is the executable that is running now. And then it's going to call this function with the executable path. Then this thing here is the one that is going to search for that pattern on the file. And if it finds that, then it's going to change the behavior of this dir access file, so that instead of using the dir access, it uses the other class here, the dir access pack. And this is kind of like creating a virtual directory structure, which is an abstraction that the code is going to use to search for the paths of the scene files. Instead of using the RAS special path, it's going to search using the abstraction that this class creates. So that's basically how it works. So this would be the executable path there, and then it's going to try to find. So it opens the executable file, and tries to find the same patterns there that you write on the export. Chart this macros here, and then at some point it's gonna search for the package, I think. I forgot where it is. And maybe it doesn't search here, searches somewhere else. But I do remember that I saw the package string on somewhere here. Yeah, it's probably this. Yeah, I'm not pretty sure. So now I'm gonna explain the one that I have there. So I basically copied most of the stuff and then I just changed some things. So mine is for like automating. So I automated the process basically. Just basically getting everything and then just hard coding the options. I forgot where I saw the package symbol there. There was somewhere else that I saw this. Is user section. And maybe just on the export. It seems that it's just on the export. Oh yeah, so on this function here, when it calls this OS function, it's gonna try to get the package thing here. And it's gonna use this on this other one here, which is the one that I was seeing before. So this is the one that it calls from the globals setup function from the project settings. And then it uses this offset to see if the executable has the embedded data information. So my thing is basically the same, but I did it in a different way because I think that the way that I did it, like at least for now, it seems to be working. So one of the mistakes that I made was the path here. So I'm basically I getting so this is the entry point for the export pipeline that I created. So this function is gonna get the bin folder for the source code, which is where the final executables are located at when you compile. So when you run scones. So when you run scones from here, it's gonna put the final executable on this bin folder, which are the executables that I'm gonna use for as templates because I have more classes because I'm creating modules. So when you create additional classes on the engine, you need to use a custom template. Otherwise, the template is not gonna understand. So you're not gonna be able to run the final export because it's not gonna have the classes that you created and then that the project needs. So I'm just looping over that folder and I'm getting all the paths. So it's basically looping over the binary, getting the paths for the final exported templates. Basically looping over this and getting the paths here. So these paths here. Then based on these paths, I also create a custom folder for the project inside of this Cortex system, which is gonna be here basically. So it's the path that I want to put the exports on. So I create this based on this here. And this just formats the string to put the root path here. So I'm getting the relative path, which is the exports. It's basically the path to this folder here. And then I put this together with the project name. So I use this as the base one. Then if it doesn't have the directory based on the project name, it creates the project, the folder here. So this basically creates the Lumina folder, which is the current project that I have. Then I'm looping over all the executables that I have there that are going to work as a template. And then at this part, I'm going to have to change. So when I do the web version here, I'm going to change this. So yeah, but basically now I'm skipping everything that it doesn't have the X extension. So it's not executable. And because I wasn't doing this before, I was trying to run the pipeline through the console version, and that's how I got the wrong thing there on the package, because the console-based template has different sections than the normal one, so it doesn't find that package string, and then it gives an error. And then it tries to run the normal one from using the same file as the other one because of these patterns here, so it didn't work. But basically here, I'm splitting based on the dots, and yeah, because of the format that it is here. Then I can get the information for the platform, the architecture, and the name. Then this basically gets I build the final path here, which is going to be the name of the thing here. So this is the target executable name. And I have this is the final export path, which would be the path here. Which in the other case was the test.x path. Oh, the project's resources I'm passing as a vector here because I decided that it's probably better to decouple because I'm building everything from C++. So I build all the resource files first, and then I put them on this project. I build all the assets first, put them on this vector, and then I pass the vector to the function instead of getting from using Edtior file system. So I'm passing the project name, the base engine path, which is the template path, and the architecture, and the final path to export. So this is the entry point function. It's basically the same thing. It's going to get the template path here and add this library or the allow stuff. Then I'm creating the other temporary path, other temporary file to write the information to. This is basically the same, just copied from how they did it. And here I'm calling prepare template with the template path and the package path, which was the original one. I think in my case I'm using the same one. Yeah, so I'm not creating the other one, I think. Oh, maybe I am because I have this embedded here. Yeah. So yeah, I am using the different one. I'm not sure if it matters. I think it probably matters because the operational system, but then here I just simplified, but it's basically the same thing. So I just left the parts that I think it matters. Just copying the data using the d-axis for the template and the console version. The other one is basically the same. It's gonna use rcedit. So this is different because I put rcedit on here instead of using the editor settings. It's basically the same. Receive the package name, final export path, and the project name. And then I get the icons based on different paths as well, which are predetermined based on the project. So for the icon, I'm using this path here. So Cortex, which I'm making based on the same name of the project there. App icons here. So it's just going to be the name of the project and the SVG. For the splash is the same thing, but a different path here. So this basically gets it creates the temporary files as well. It just got the same function, changed the name. So it creates and here I'm doing based on like this standard format here, which is also based on the project name. And then later I might use a JSON file, which is the reason why I wrote this. So I can put on this project's metadata folder. Then I open the JSON, I write the information for the project on the JSON, and I get the settings for the project here. But for now, I'm not gonna use this. I think I'm just gonna use the standard thing there. Then it's basically the same thing. The biggest difference is gonna be the RC edit path, which I'm getting from the hard-coded path here. So Cortex, then this path. Then I call the same function that they call there. This passes the package path to this one. This one's gonna save the data as well. Then here I just did it different because I'm not using class, I'm using functions. So I'm just passing this for Windows is gonna be true. So it calls this, which is basically the same function that I have there for the embedded version. And I think the main difference on this one is that I changed the way that I'm writing, but it's basically the same thing. I'm just passing the struct here, writing everything to the temporary file. Yeah, the main difference is that I'm passing the resources as a vector. Yeah, the rest is basically the same. Yeah, so here I remove the plugins related stuff. I'm just looping over the resources which have the asset paths. Then write to the file, temporary file again. And then this part is different because I just hard coded. I copied from the other function and just put on this one. So basically writing the icon, the splash, in these resource cache files, using this function as well. And then here also, so I didn't put this in the beginning and it couldn't find the project, so that's how I know. This part is the one that allows the executable to find the project because it's saving the project settings using this function here on this temporary path. So in my case, I didn't put remaps because I'm just using the scene files that I created in the beginning. I'm not creating temporary scene files. The rest is basically the same, and the only difference is on the other function that is gonna calls the embedded here. But it's basically the same, this one. It's basically the same thing. Yeah. So I'm gonna run from here. And now what I'm gonna do is work on the web version. So I think I'm just gonna copy, I'm gonna go over with the debugger again on the editor version, but for the web template. And then I'm gonna copy the functions on the class that I have there. Then I'm gonna test to see if I can export, because I figured out how to create the compile version, the custom compile version for the web. Using ChatGPT, basically I have to download some other stuff there. You download this SDK here, and this allows you to create WASM files, WebAssembly files, and Godot uses this to create a compile version. So on the scones logic of Godot, they have stuff that is going to look for the environment variables. It's going to look for the path of this SDK here. And then Godot is going to basically use this SDK to compile the project, and then it's going to create files on the binary, which are these files here, and it creates the zip as well. And the zip is the one that you use when you are exporting. But when I tested there, it didn't work, but I'm not really sure. So what I'm gonna do is just try to copy the way that they do it, the template, and try to automate, put on the option that I have there. So yeah, I think the first thing I'm gonna do is change the condition for the extension there. Then I have to copy the functions. Yeah, so this basically created this files here. Chart these files here, which allows me to run the project. Yeah. And the console opens the console here. and it doesn't run if you put on another folder. Yeah, so you see that opens something there and doesn't do anything. Because this console here, since it didn't do the last part of writing the assets to the actual executable, it relies on you having the package data or .package file with the project info in the same folder, or having another executable that has the package info embedded into it, and then it runs. So I can change this as well there to write the information to this console. But the problem is the sections there. So in the console is going to be different, the sections. So you have to manually change, figure out how the sections are structured, and then change how it works here. And I don't think I'm going to put the time because I don't think it's worth it to do this. Yeah, basically in this part here, I would have to figure out how to do the same thing but for the console version, and also call the same function there to save the rest of the data on the console as well. Yeah, so the first thing that I'm gonna do here, I think it's gonna have to be zip. No, actually maybe it's WAV. The platform is the second one. So when you split here, I think it's gonna be the second one. Yeah, so it has to be WAV. So it is correct. So let me think. And maybe if I put an R, just do the same. And this is probably the best way to do it. Yeah, for the rest of the stuff, I have to see. The main thing that I need to write is the paths. So the template path. I need to see the formats that they use. Maybe the template, yeah, template path doesn't matter because that should be the one that I have there. What's base ancient path? I think that if I do like this, it's gonna skip. I'm gonna try like this first. There's something weird going on. I guess it's because it's not um, stopping here. Yeah, it's not gonna work. The problem is if I put, I don't want to wrap everything around the thing, and I can use the exclamation mark to change that thing, but maybe just put else here, like if equals. I guess I can do this and put there. Let's see if this works. Okay. It's probably because it's an address, I think, and the arguments. Oh no, I put on the, yeah, I put on the wrong thing. I'm gonna run again. Yeah, but it doesn't matter because I know that it's gonna be the correct path and it's gonna be a zip. So what I'm gonna do is just go over with the debugger here again, and then I'm gonna select the web version. It's kind of similar. The web, I think the web, I'm pretty sure uses the same function that the other ones use. It's the export project data, I think. It just has a different function before. So what I'm gonna do is just create another file here for the web export, the same format as the other ones. So I'll go over with the debugger, then step into copy the functions. I think I'm gonna copy everything first on one file. Then after I copy the whole pipeline, I just figure out how to remove. Yeah, so it's basically the zip. Should probably remove this breakpoints. So I'll be right back. And when I come back, I'm gonna go over this. This is another thing that is kind of annoying on the web is that you have a lot of other options. I think probably the one like obviously the one that I'm gonna focus the most is gonna be Windows because that is the one that I'm using. But I think web is probably the next one. Then Linux is gonna be the third, and the reason why is because of the compilation process. Like in order to create the templates for Linux, I think I need to be on either I need to be on a Linux machine or I need to use WSL, or maybe there's another way if you use like executables, but it's just more annoying to do it, I think. And then there's no way to test as well unless you have the virtual machine, I think. I'm just gonna do the simplest version, probably. Maybe for mobile is interesting as well to mark this. That's why. So you need this texture compression. Let me see. I'm gonna write this here. The problem is I'm gonna have to, if I want to make this work, I'm gonna have to figure out how they do it from C++, then put on the code that I have there, which might be annoying. I don't want to spend time on this. Hmm. See something. I'm gonna ask this to ChatGPT. I'm also using DeepSeek now. I think sometimes DeepSeek is better, and it's kind of weird with ChatGPT. Like some situations, I'm getting very bad responses, like that makes no sense. But then some other times I get very good answers. So I think that either they are like changing the model based on the user. Like sometimes when there are messages that they show here, or it's because of the context of the message. So this one it thinks before when you have the deep think R1 here. Yeah, so it is that those settings there. So let's do this. Yeah, so here it starts. Well, actually, I think that is basically the same thing. The only difference is that it's going to write the information to the package file, and then it's gonna put the package file inside of the zip. It's basically the same system. I'm gonna copy this, obviously. Unless I can go manually and just copy everything. I think this doesn't matter. And this is a problem. Hmm. Let me think of this. 3, 4, 3, 4. Oh, no, it's different. This I think is gonna be true. True. Save pack. Oh no, it's main pack. Hmm. 1, 2, 3, 5, 6, 6. So inbound is false by default. Yeah, it has to be false, obviously. If it's gonna write on the package. So here's gonna be false. 4. On the exports. Also, it's getting the image on the other one, and here it's getting the path. It's basically the same. So global gets strip edges, path, and then loads the image, and returns the image. Okay. So yeah, probably the easiest thing to do is just write down the all the functions that it uses there. So this part's gonna be all the same. Just passing the package file instead of embedding. I'm gonna save, blah blah blah. We're gonna write everything. So I think you can skip this. And here, this part is, yeah, but it doesn't use anything. This is definitely one of the functions that is different. I'm just gonna copy. So probably copy all the functions first, then change the add messages thing for warning. Then it's gonna change the name, input web, export prefix to make sure that all of them are unique, the name. I'm just gonna copy for now and so change later. So once I have all the functions, then I'm gonna replace these messages here with a warn message. Then I'm gonna include everything that it needs to include. And see if I need to change anything else. Maybe it's easier to... I know that this zip stuff here... Actually, there might be... I think that most of them come from a third-party library, but there might be some from Godot classes. Yeah, third-party minzip. It's probably better to just use F12 on VS Code to find the definition and then include everything. So I'm just gonna go back because it probably doesn't matter that much. Just writing to the zip. What is this? PWA. Progressive. So in my case, this is gonna be false. Progressive web enable. Oh, it's because I removed. I don't know. Oh, fix HTML. Right, sorry. So I'm just gonna copy this as well. Already gonna remove this. So, Yeah, this one's probably better to copy and then remove based on the thing there, like based on the flow. But it's probably not gonna have any flags, I think. I'm just gonna put a comment, then I'm gonna look at the settings from the editor. I can see from here. So this is localhost, remote part 6. And so they are all false. And so if they're all false, it doesn't matter. It doesn't push any of them. I should probably write all of this down. I took an image. I'm gonna replace. Actually, it's probably better to, as I go, to hard code the values so that I don't have to run again or look into the editor to refactor later. I fix HTML. So I'll be right back, and I'm gonna use the image here to replace the values. I'll be right back. It's gonna be a boolean. It's true, man. It's already here. Mm. Yeah. Yeah, so I think that's pretty much all the export process. So now what I have to do is just refactor the parts there. I'm gonna start with this. backgrounds. Science. This is kind of annoying. So this is a file generated on build time. And it's probably gonna be, it has to be based on the build system. So let me think. So obviously one option is to do the same thing that they do there, but it's kind of annoying. So the way that this works is the same way that the icons work from the default theme and the editor theme. They write the binds into a file, a header file, and then they include that header file that is generated based on the build time on the other files. And then it allows them to get the information with the numbers like this. So I assume that this is a default Bootsplash image that they use for the web exports. Oh, this is the one from the. Actually, this is the one from the main. Yeah, so I can include there. Or this was the other thing that I was gonna say. I can use the main one, but I forgot how they do it. But it's somewhere along the main when it's loading the project or like on the main setup is going to try to search for the splash image on the project, and then it's gonna use the server to load the default one. So obviously I'm just gonna do the same thing. Like if it was a file specifically for the editor, then obviously I couldn't use. So maybe the easiest way is to at these ones I'm gonna comment everything out, I think. So the other thing that I have to do is to remove the preset logic. Mm, I'm just gonna remove this. It doesn't matter anyway, because I'm not gonna use this. If I should change the name. I think it's probably not gonna work for, but I'm gonna leave it. If it doesn't work, I'm just gonna leave it like this, and then once it gets time to, once I have like a real, yeah, I think I'm gonna focus more on development iteration speed first, because I'm not really sure if this thing that I'm developing now, I want to deploy somewhere. I think I'm just gonna use that for myself privately to develop fast, and then the projects I build with that, I'm going to deploy. So since I have on this one, I don't think I need to include here. And for the zip ones, it's probably easier to compile and then see if I get errors. Just gonna comment out this function because it's not gonna be used. I think off stream I'm gonna go over again. Then I set this option to true and hard code the values. Just wanna get to the point where I can run this, shoot test to see if it's gonna work. Two, three, four. True. These ones I know. 24. HTML name, shared objects. Size. And now it's easier to compile. To see the error messages. Oh, I forgot to forward declare here. I think this one I'm gonna have to. I'm not gonna. Just gonna include here. It's easier. Object of content. Image. String. Always forgets a type name. Raise is struct. It's a class. Sure. Struct. const is only allowed in classes. I always forget about this. I think that's what it means, is basically saying that the function is not going to change a member variable state. Whatever. The problem is that this function is not from a class. Hmm. So how can I get this? You just I'll try to do this. I'm not sure if it's possible. I think that there must be a singleton for the theme. So I'm gonna ask. So I'm gonna try to compile like this, and then I'm gonna ask ChatGPT to see, or DeepSeek. Well, there's also the import, the settings that I didn't see anything about. So I'm probably gonna do this off stream. I'm gonna go back and the issue is that there wasn't any setting on the export. It was just the message. Actually, there was. It was the mobile one. So I need to go over the. Maybe yeah. It's probably easier to go over the source code and then search for the option for the mobile. Then search for logic related to that option and see where it matters. And probably what I'm gonna do is just set the setting before. So you can set the settings using the project settings class. So get the singleton and then set the setting based on the path there. So all I have to do is find the path to this etc, which ChatGPT gave here. So I'm probably just gonna copy this here and put this on the beginning of the function there to make it true. And then save, yeah. So I was gonna ask, yeah. Hmm. I'm gonna try this option here. That's from the control. Actually, it's probably like I think I'm gonna leave it. So what I can do here is use a control and then use menu to initialize, and then call from the control class. Because this is gonna search for the thing that the control has, and then it's gonna search for the default thing. If you can't find the icon, so it's just gonna get the default icon from the default thing which I put there before. So I think this would work, but I think it's probably better to just put a message here. And because based on the way that I'm doing things, I should always set this application config icon on the special path there, the relative path on the Cortex. So I think when I don't have this, I should probably just return the empty image and I should send a message here instead, like an error message. And that's gonna remind me to put the icon on the path there. It's probably better than choose the default one, which is the Godot one. I think it doesn't have any extensions from what I remember. I forgot to write down. Yeah, I'm gonna put without any extension, because I think it's just gonna build. It's gonna be based on their architecture. Uh, Project name. Yeah. So I'll be right back. I didn't create the zip though. Hmm. It's gonna be. It's weird. Maybe it doesn't matter that much. Just compress here. I'm pretty sure that the editor one does compress though, so I probably forgot something. It has to be one of those files that is not working. One of those functions. Yeah, it's whatever. So now what I'm gonna do is put the folder or the zip on the downloads. Then I'm gonna extract the files to the folder. Let's see. It does seem that it exported the package, the JS icon. I think it exported everything that you should need. So I'm gonna open. So there's two ways to run a server. One is to use Python, the other one is to use the live server. The two easy ways. ChatGPT recommended the Python way. Trying to see if I still have the thing. And it opens on localhost 8000. Yeah, but it's not working. It just shows the files, but it doesn't show anything. And it's the same problem that I was having before. Just uncaught reference, Godot config is not defined. But this is what the same thing that I get on the editor export. So I think that besides the zip thing, I did everything right. And it's just an error with like something else. It might be a project setting or something. So the question is whether or not I should try to solve this now. Let's go to config. Let's see if there are any videos on this. So there's something wrong with the parsing, I think. Think about this. It can't be the dollar sign because the other ones are working. So I assume the problem is that for some reason it's not getting the values, and I assume that has to do with the options. Like these two values here are not correct. So let me think of this. Maybe because of this. Okay, so one of them I know is because of this. Like, for some reason, it's not parsing correctly. Like that, this is supposed to create a dictionary with the values, and then it's supposed to write this into the HTML. So I think this is supposed to be a dictionary on the HTML there, but it's not. And the other one is the URL. The URL, I'm not really sure. I think it's because of the file path. So one thing that I can do is simplify the path. I'm gonna delete the files here. I'm gonna remove the architecture from the name. The platform. So remove this. I think the architecture. So I'm gonna leave it like this. Maybe I should put an underline as well instead of a dot. I'm gonna put an underline. I don't think this is gonna solve. So I'm gonna go over with the debugger and I'm gonna put a. I wanna see what is happening on this one. Oh, the other one that I was gonna look into is the URL. So URL is probably based on the name, and the config is probably based on something going on with this conversion here. Let's read the name just. Yeah, so. Yeah, the thing is, if it was because of the name, then the editor export would work, I think. But I don't remember if I got the 2 errors on the editor export or only one. Actually, I'm just gonna. It's gonna take too long. So I think I'm just gonna stop streaming now, and I'm gonna try to figure this out off stream. Because I'm probably gonna go over with both, go over again both on my stuff and on the editor, just see what are the values, and then I can try to manually change on the site as well, to see if it's gonna work. But I don't care that much about this now, so I think I'm not gonna invest too much time. If I can't figure out, I'm just gonna go back to developing the thing. I just wanted to get to this baseline now, so that in the future, when I get the MVP for a project that I actually want to deploy, then I can go back and spend a lot more time figuring out. The other parts was the URL that I didn't see. Yeah, I'm just gonna run. I have to delete this. Yeah, now it seems also to be wrong. So this file here. It should be wasm, but whatever. Yeah, it should be JS. So it wrote the wrong name there. So I'm manually changing the extension. One of the files should be on the already exists. Yeah, so there's something wrong with the name. I'm just gonna delete the file that doesn't have an extension. Actually, I might need this file. It should be the. Oh. Yeah, I'm gonna delete the file that doesn't have an extension. Alright, same error. I think I'm gonna stop streaming here. I'm gonna try to figure this out off stream, but probably I'm not gonna talk about this anymore, because I already got the main one that I was focused on is the Windows export, and now I'm gonna focus more on the developing fast, developing the thing the IDE thing that I was building. Maybe I'll talk about next time that I stream, I'll talk about in the beginning of the stream how I solve this, and then I'll continue. But I don't think I'm gonna make it uh, a stream just to explain this. And it's probably to do the values there, so I'm gonna have to spend a bunch of time going over with the debugger on both builds and see what is going on with these values. Yeah, so I'm gonna stop streaming now. So next time that I stream, I'm probably going to continue developing the main scene that I was building before. Let's so the next thing that I have to do on the other one is to create a simple terminal class, and then I'm gonna have to figure out how to finish the class that is responsible for creating the files. So I need to create a parsing system and parsing and highlighting system, and I need to create a bridge between that and the other components. So I'm probably gonna think about upstream which one to do first. And I think I'm gonna do the beginning of the terminal doc first. Then once I build the terminal, like the basics of the terminal, just to have something that I can run commands. Because then I can run everything from the IDE scene instead of using VS Code. Well, the other thing that I had to do is a scale, but I think it's not gonna be that hard. So the hardest one is gonna be the parsing. Figure out how to parse and highlight. Oh, the other thing I have to do, I think I'm probably gonna figure this out first, is to instead of having the window from the operational system, to remove the window and have the and create a custom navbar to close the window, because then it frees up more space. So that's probably the next thing that I'm gonna do, because it's relatively easier and it is very annoying to have the window from the OS because it takes too much space. So I think this and the scale is probably the next thing that I'm gonna focus on. Then after I do this, I do the doc. Then after the doc, I probably come back to the the file system and then focus on the parsing. Yeah, there's another class that I have to focus on first as well, I think. But I'm probably gonna have to develop both at the same time. So like the VS Code doesn't have the window here. They create their custom one. That's what I'm gonna try to do, I think. So replace the window from Godot with a navbar and then create these icons. And maybe I should spend some like more time trying to figure this out now. I'm gonna spend like half an hour. I'll spend half an hour more just going over the editor export system. Yeah, so I'm gonna spend half an hour more. I'm gonna go over the editor exports. And I'm gonna see what is creating. Let's see. So there is this one and the URL. The problem with the editor one is that actually, yeah, before I do the editor, I can remove the class there. So I'm using a class that the default engine doesn't have. So I think I'm gonna put the default class because then I can test. Yeah. Oh, they do HTML. So I'm gonna change here. Just realize. Maybe, so I'm gonna run this one first. 'Cause I think it's probably not gonna work, but I just wanna see the files when I put the HTML extension. Alright, it's still this one. Yeah. This is the class that I was talking about. I'll do without this one for now. Okay, so now I'm getting a different error. Interesting. So it probably does have to do with the name. So cross origin isolation. Send correct headers. So this is one of the preset options there. So what I'm gonna do is just remove that option for now. So I follow ChatGPT instruction here to create another server using npm, but it's still the same thing. I still giving the message. So probably forgot to turn off from some other place. This. Okay, so I think it is working. So probably what I have to do to solve is something to do with the paths there on the one that I have. And then obviously I can figure this out later. So I have to change the way that I'm initializing the server, or I disable these features, but I think it's probably better to figure out how to run the server with these options here because they're probably safer. But I think that's if I do this, it's probably gonna work. So I'm gonna try to change this just to see what happens. As memory buffer. So obviously the easiest way is to remove this. If it doesn't work, I remove everything. It's not defined. Yeah. It's because it doesn't have. Yeah, so it's just gonna give a bunch of errors because it builds with the thing that I don't have there. Yeah, whatever. So I'm gonna stop streaming now because I think that's gonna take a lot of time to solve this. So I think next time that I stream, I'm gonna do something else, but then on the beginning, I talk about how I solve this. So I'm gonna spend more time. I think I'm gonna go over again with the editor, and then I'm just gonna write down all the values. Then I'm gonna go over with my thing, and then I'm gonna check to see like the differences. Then change the code. Then after I do this, I'm going to figure out how to run the server in a way that allows me to see if it works. But I think that's probably gonna work once I do this. Then after I'm done with this, I'm just gonna continue to develop the IDE thing that I'm building. So yeah, not sure how long I'm gonna take, uh, or when I'm gonna stream next. So probably a couple of days from now. So yeah, see you next time.